All righty. Well, I'd like to wish a very good morning to all my colleagues online. Welcome you to the most recent version of the Earth Science Seminar Series. I have the real great pleasure and honor this morning of introducing a colleague that I've had the pleasure of working with for quite a long time now, for over 10 years. In my time at NASA, I've had workings with creative people, with driven people, with motivated people, intelligent people, and occasionally with visionaries. And Aaron is one of those. Aaron's a visionary. He had a vision over a decade ago about what a collaborative, immersive science portal would be, and how he could leverage his doctoral work in kinesiology and physiology and human factors. I mean, he's put all these things together and come up with a system that he calls the Mission Tool Suite. It has been wildly successful and is absolutely brilliant. It's one of the I think it's one of the coolest things that's ever come out of NASA. So without any further ado, I'm going to introduce Dr. Aaron Duley and take it away, buddy.
Oh, thanks so much, Don. And yeah, I really appreciate that introduction. I guess just to start things off here, my name is Aaron Duley, as Don mentioned here, and I've been at NASA for about 15 years. And I switched over from Constellation, Project Constellation was at the time. I was doing information architecture, semantic technology work. And once that project ended, kind of found myself in airborne science, not knowing anything about it. And Don Sullivan and along with Matt Flalin, one of the first few people that I met who've been really participating and doing some really groundbreaking, awesome stuff, pushing the envelope of airborne science technology. And I really kind of felt, very fortunate to have, come across both those individuals, and really appreciate their mentorship and all they've done for the program over the years. So that's kind of my basis for trying to have created this tool to really kind of complement the stuff that they've done and showcase some of the work they've done in the network sensing arena. So I'm going to turn off my camera here just for the sake of conserving bandwidth. And I think Don's going to monitor the chat. So if you have a question, you could pop it in there. I think at some point we could stop for a break and answer any of those questions. If not, we'll make sure they get answered before the seminar is completed. Let's see here. So give me 1 second. Okay. So along with Don, and I mentioned Matt Flalin, there's been a number of collaborators who, I've had the pleasure of working with that have kind of participated in one way or another the development of the Mission Tool Suite. And these individuals are listed here. There are others, of course. But, I really have been fortunate to work with such a dedicated group of people who really strive every day to improve Airborne Science Program, but also the overall advancement and technical capabilities for the program itself, because those translate into powerful capabilities for researchers and really do advance the nature of what we can do with these platforms. Okay, so for those of you who are not familiar, the Airborne Science Program is part of the Earth Science Division, which sits within SMD. And SMD obviously, as an organization within SMD, the Airborne Science Program is responsible for providing aircraft systems that further science and advance the use of satellite data. And for those of you who haven't seen it, you can go to the Airborne Science Program website. You could take a look there for the type of program and activities that the type of activities and things that the program participates in. And it's got a lot of real good information. And I encourage you guys to check that out. It's Airborne Science, nasa.gov. So what you see up here is kind of when the Mission Tool Suite took off. We started kind of development activities probably around 2011. And you can see the nature of the Airborne Science Program. It's a global program. And in that kind of shaped the nature of the tool, which I'm going to be describing shortly here. But it's a fairly active program as well. And you can see this is program activity since 2012. Okay, so within the program, close this list here. Within the program, there's a number of different platforms with varying capabilities that are used to collect scientific information and do all kinds of things from satellite calibration, validation, instrument development, you name it. And they vary significantly based on capability. And this is important because when we're talking about developing a decisional support system, some of that is driven by the nature of the aircraft itself. Some aircraft, you have instrument operators on board next to their instrument collecting data. For others, they're completely uncrewed, and everything that mission science team or an instrument operator or PI gets is coming to them telemetred over the ground. So the nature of the actual aircraft somewhat dictates the importance of a collaborative and situation awareness tool. And this next slide is taking that table data and plotting it, showing the aircraft endurance and performance capabilities. And the other piece of this here is the nature of how long an actual aircraft flies. So in addition to whether or not it's crewed or uncrewed, the other piece of the puzzle here is how long is the aircraft in the air? Is an aircraft going up simply collecting a line and not making any dynamic changes during the flight, or is the nature of the phenomenon that the aircraft is going after dynamic and needs to change, or is it up in the air so long that you have this capability to do this tactical mission replanning, and the supporting tools that need to be there in order to do that become more and more important. Let's see. So as a carry on to this, this is one of the things that I know Matt Flavin's involved with. But you're going from Global Hawk, which used to be part of the actual Airborne Science Program, which it's not anymore, but flew several tropical cyclone flights mainly over the past decade, many of which we were a part of. And in that, when it's you have an aircraft and a platform that's in the air for say more than say 25 hours, the capability of such an aircraft where you have staff changes, you have to be able to establish context, from your getting in, having some kind of staff change shift. All this stuff becomes very important, and the nature of the data and the way in which you get information to the ground and to, I say, a distributed team of people becomes, I think, more important. And then this, over time, you could see some of these other types of platforms that are being developed that might not just be in the air for 25 hours, but say for a month at a time, might really change of the nature of the type of tools that need to be there to support the type of information that's being telemetered and what ultimately mission scientists want to be able to collect on the ground. Okay, so if you haven't seen an aircraft before, typically this is like a prototypical example with a DC-8. I don't know how the video is coming through, but you have an aircraft that has a bunch of instrumentation, not only on the sides, but within the wing, sometimes at the bottom and the top of the aircraft. And the instrument, the DC-8 is one of the workhorses of the program. And, in this particular case, you have all kinds of information that's available to researchers and folks who want to be able to get access to that information that may not be co-located with their instrument. There might be a team of individuals who aren't able to fly along with the instrument, but may be participating and want to be able to not only use that information for instrument status, but may want to be able to take that instrument status and provide it to a broader team such that they can make decisions. So some of you may have seen this slide before, but within the Airborne Sensor Facility, there's been over the last decade and maybe even a little bit longer, this airborne sensor network that's been developed. And this is kind of where the mission tool suite kind of came into play. You have all this information that's telemetered to the ground. What people on the ground want to be able to use, they want to be able to see and use that information to make decisions about what's going on in real time. And they want to be able to look at that in concert with other products that they might be seeing that are relevant to the actual mission. So in addition to kind of the payload piece of the puzzle, there's also the product piece. And those two things really need to come together to really give a full-fledged decision support system and make that available for any kind of decision-making that needs to happen during one of these flights. Okay, so what is MTS then? So it's a lot of things depending on who you are. And, from kind of a broad brush stroke, an information system that supports tactical decision making and distributed team situational awareness during airborne research mission operations. And we say tactical decision making because, strategic is we're going to go up, this is the plan, we're going to fly, and there's not the thought that there's going to be any kind of changes. It's fixed in nature. And the notion, and there's lots of airborne science missions like the UAV SAR. What they're going to go up and the plan they're going to execute is fixed. And there's a lot of other missions that are very much opposite of that. One which we'll look at today, which is impacts, which is very dynamic in nature. So kind of what our target is, certainly, if someone wants to follow a mission and get some type of situational awareness, whether or not an aircraft is up in the air or not, that's information we've provided, but there's a much more richer information set that needs to be there to support those who need to be able to execute a mission dynamically. So another way to think about MTS is that it's an IT system that encourages collaborative measurements among instruments on airborne science observation platforms, Earth sensing satellites and surface measurements. And the sole goal is to improve the efficiency and effectiveness of flight missions. So you're really taking this airborne, ground and spaceborne instrumentation, and you're making it available to really kind of complement each other to provide and paint a much better picture than you could by looking at these individual things in isolation. So it is a web-based tool, so it's accessed through a web, through a browser. And the idea is to look and view meteorological and other airspace information in real time and kind of, again, as I mentioned before, look at all this information together in a single environment. Okay, so it could just be, if depending on who you are, a web page for monitoring aircraft position. Maybe you want to be able to chat with a team who's in one of the aircraft. That's something that's people use it for. Some people just use the tool for downloading flight trajectories and or for a source for just viewing instrument telemetry. And any of these things are reasons, and depending upon the stakeholder and who you are, that is, MTS might be slightly different based upon who you are and what role you play within a mission. Okay, so I guess just to kind of frame, the precursor to MTS, and I just kind of wanted to have a slide here to just briefly about that, and talk maybe just briefly about the motivation for kind of these collaborative applications in general. So collaborative applications, things like Google Earth, applications for distributed team, it has a long history. However, the shift for the Airborne Science Program came probably in the late 2000s, where geospatial technologies like Google Earth become widely adopted within Earth sciences, not solely for visualizing satellite imagery, but operationally to visualize the position of airborne platforms relative to that imagery. And so CDE was one of these first applications to do such a thing, where you have Google Earth, but then you have Google Earth where it's getting real-time aircraft information, and then that's paired with imagery that's relevant to, in this particular case, a fire. So back before that, the existence of like crewed platforms, such as like the WB-57 and ER-2, and uncrewed platforms like the Global Hawk, instrument hardware and mission operations were decoupled from one another. And for these platforms, how do you disseminate mission status, aircraft status, and instrument status? Because it needs some way to disseminate and get that information out to whoever the team and wherever they might be. And so this is in contrast, obviously, as I mentioned, where you have platforms like the P3 or a C-130 or the DC-8, where the instrument operators are right there in situ with their instrument. So the emergence of kind of web mapping applications, it gave rise to a number of tools developed in NASA to support kind of airborne operations, and there were a number of them, developed at Marshall. Some of them were developed by NCAR, and they were developed in kind of isolation of one another, but they all kind of had the same kind of common goal. But for NASA and kind of for airborne science as a whole, the addition to providing this common set of tools that provided not only situational awareness for mission activities, But there were a number of motivations by the community and from program management that drove support for kind of how MTS kind of came to be. And some of those include leveraging existing ASP investments, acting to eliminate IT redundancy or effort duplication from one mission to the next, reducing NASA Science Mission Directorate and program costs, data analysis program costs, and then kind of providing the single point of access for mission planning and execution. And that's kind of the lead in for MTS. And we started back in about 2010, where it wasn't really MTS at the time. We were really just kind of working with the kind of ground data system that was available. And then over the last decade, the tool has kind of been evolved from one mission to the next to really kind of capture the things that those individuals or mission scientists or people in the team needed to make the most value of the information that was coming to the ground. And that changed over time, and depending on the nature of the SMT focus area or whatever the phenomenon was trying to be targeted, we would get requests for certain types of features, and those would vary considerably. And what we would find is there would be common themes, and we would improve that tool, let's say, from one mission to the next. And then in other cases, it might have just been, a single use only, and, it made its kind of way out of the tool. But what we've done now in 2020, we released kind of what the second version of the tool looks like. And this is kind of what the MTS tool looks like. There's a lot more to it, but just to kind of step through what the interface is, I'll do that in a second. But it's kind of what you'd expect with a situation awareness tool. You have the ability to kind of view real-time aircraft information on a map, coupled and paired with any kind of like product that you want to see. In this case, it's probably some type of GOES enhanced imagery. And then you can see the tracks. And this was, I think, right around the time of a CPEX mission. So you can see the DC-8 here at the bottom, and you can see some of the NOAA aircraft that are involved as well. And over time, that's kind of what we come to support is we've supported NOAA hurricane operations because NASA and NOAA not only are customers to one each other, but we wind up occupying the same airspace quite a bit of the time. So anyway, I'm going to step through here on some of the other features, and then we're going to dive in and hopefully show a demo in a second here. So in addition to individuals wanting to be able to see telemetry and aircraft position, we've also had several requests for workspace customization. So what you wind up having with a tool like MTS is you have a number of people who have different roles within a mission, and those stakeholders want to see different information. So this MTS2 is set up such that you can customize the environment based upon your own preferences. So you might want to be able to view multiple maps. You might want to be able to compare multiple satellite images. You might want to be able to see some camera from one of the onboard cameras if those are available. So there's a lot of information that's available. And the question has always been is how do you structure that information and make it available to end users such they can customize it based upon their needs. So for the new environment here, just to kind of step through kind of what this looks like and how this kind of comes together. At the top here, we have kind of the key functions of the tool. So you have the status view, which is on the left-hand side, which is there in blue. You have a way to view products, and that goes on to tools, chat, and settings. And hopefully I'll demonstrate this in a few minutes here. But at the top, you also have the ability to search across products. You have the ability to search not only products, but if you want to bring up other platforms, and those include spaceborne platforms, satellites. And then on the left-hand side here, what you wind up having is a way to view platform information. So you have a way to simply view platform telemetry. And what you see for this example is platform telemetry, which is the housekeeping data, which is also known as IWG1. There's the complications, kind of borrowing from watch parlance. It's anything to do other than just tracking the aircraft itself. So what we find is that for individuals trying to not only plan and have some decisional support capabilities based upon the aircraft position, is they want to get some sense of things that can give them spatial distance as well. So providing range rings, ways to view the aircraft position, distance, and ETA to some point in space, or to maybe some other platform. All of those things are kind of rolled into this kind of complication section, which makes it very simple to turn this functionality on or off. There's also a real simple way to add additional platforms and satellites. So what you wind up having is sometimes you have these kind of core platforms that are relevant to a particular mission, but then maybe there is some mission that's going to be flying that is maybe occupying the same airspace, or they have shared goals, and you can add in those aircraft as needed. That happened with DCOTS, for those of you who know that, and those people want to be able to view the 8-clip WB-57 along with that aircraft. So it makes it real simple. The tool makes it really simple to do those type of adjustments. So there's displays, which are map displays. There's also quick look displays. And this is an example of a camera quick look display, but this could be a quick look from an instrument as well. So oftentimes we have instrument teams that are generating these quick look type plots on the ground based upon the information they're getting from their instrument. They make that available, and it's they push that to the system, and it makes it available to everyone who is interested in seeing that particular product. There's ways to display and switch these options. So if you want the camera at the top, camera at the bottom, if you want to view visualization like a plot, all of that stuff is built into the system. And again, this is all just a web page. So structuring this and making this available, again, flexible enough that it is customizable for stakeholders who have very different objectives in some cases, but also doing it in a way that is technically possible in a web page is a challenge in itself. So just to talk briefly, and I won't dive too into the technical weeds here, but I just want to talk at a high level, kind of when I say MTS, there are all the things that I had mentioned before, kind of the high level, but as far as a technology program itself, MTS is really kind of broken down into a few different pieces. And one of those pieces on the left side is data services. So because we kind of fall at an intersection of remote sensing and airspace operations, in addition to, kind of needing earth science type products, we're kind of in this position where, it pays for us to be able to get access to not only aeronautical information, say from the FAA, but there's all types of data services that are kind of core to our system, which we ingest and then make available within the tool. And these are there regardless of your particular mission, because they have generalizability across missions in general. So like any type of meteorological information, TAFs, that type of information obviously has relevance regardless of mission. On the other side, the thing that most users interact with is kind of the portal side. That itself has its own server to support, client authorization, authentication, but also data aggregation, which I'll get into in a second. And then the client application, which I had you just saw pictures of a second ago, and to support other functions within the program, like the API that supports our public tracker. Okay, so on the data aggregation piece I had mentioned, what we have set up is a FAA Swim consumer interface. And this is real powerful because it gives access to really a whole bunch of different swim business services that are relevant for people who are not only planning on the mission planning side of things, but also on the mission execution side of things. And because this authoritative source is available to us, we have this set up such that that information is available to people's fingertips who are using the user interface. And I can give some examples of that in a few minutes. There's also kind of non-swim data aggregation type information like satellite TLEs, that type of ephemeris information for people who want to be able to view satellite tracks, and then other type of non-swim information that we can pull into the system. And again, our focus is pulling in and making that available for everybody, but certainly there are projects that might need specific aspects of all these different data sources in some other way. And in many cases, they'll have a staff or someone on an actual mission who might produce some type of satellite product, which is specific to the mission needs or requirements for the project itself. And we have to be capable enough to be able to ingest that. We encourage obviously standards, but in many cases, they're not, people who generate products are not always thinking about that or they're not thinking about the way in which it's projected and other factors. And so we're a system that's set up to really adapt to any data source that people make available to us, and then make it drop dead simple for people to view it in the client side. Okay, so before I get into the products, telemetry obviously is a big portion of what we do. And the thing about MTS, I think, that sets the tool apart from other, say, ground data systems is that really it's a generalizable ground data system, in that the system is set up and it has a model built in such that we're able to bring in data from really any different type of ground data system. So some examples of that might be the Airborne Science ground data system itself, or it might be, say, for example, the NOAA AOC ground data system. And they push data in specific ways, and we have to be able to accommodate and get that data. So we have receivers that are set up that kind of abstract away how do you go and aggregate this information. In some cases, the data is pushed to us. In other cases, we go out and fetch that information. A consumer is really something that handles the cycle end to end and is the pipeline for taking data that's aggregated in some way and then runs it through a series of steps. So it's validating it, it's doing any kind of telemetry transforms, it's doing storage, it might be doing notification, it might be doing some type of semantic tagging on the telemetry record itself. And all of those things are customizable. We have, some purpose-built implementations for what's needed for airborne science, but really this can be applied to any, any place where some type of platform tracking or telemetry tracking is necessary. And then the third piece, and which is a critical piece here, is having some simple descriptor format such that the client itself can make sense and know, okay, I can plot this variable because it's a number, or I can use this as a timestamp. And having some very specific types of fields that are defined with very simple data types. And these descriptors describe a telemetry record. And then that makes its way ultimately to the client, which can then use this information in intelligent ways. So one of those ways might be in plotting with instrument telemetry. And this is an example of some of the instrument telemetry tools that are built into MTS. And there are a few different examples here, but the main piece here is that what we wind up having is customers who want to be able to not only view data together, they might want to be able to view data, separated out within different time increments, you name it. So this is all based upon that model that I previously showed, where the descriptor is describing what fields are available for a given consumer. And again, this is kind of the technical, piece, and there's more to it, but I just wanted to kind of highlight it, that there is an important telemetry piece there. And there is a lot of customers who solely go to MTS just to view their instrument telemetry. So as far as summary is concerned, the system itself is flexible enough to ingest telemetry from any third-party data system. And there's lots of examples listed here. And again, most of these are, tracking platforms. But if you think about it, there's really, any kind of limitless, you can, anything where you want to be able to track some type of asset, the system is set up to handle. There's also this ability to have these custom data processing pipelines and data validation, et cetera. And I had mentioned some of these other data schema and other stuff. But just to summarize, telemetry is an important piece of what we do. Now on the web browser side and on kind of the client side, which is the piece that most people are interested in kind of seeing, and because this is the piece where everything kind of comes together, there are limitations, based upon, what you can do. And the system is set up such that, it allows a lot of capability and gets around some of these barriers that are built in for very good reasons. So for CORS, which is cross-origin research resource sharing, there's a good reason why the browser is set up where it doesn't go and allow these XML HTTP requests, which are a way to get data into an actual browser window, and it prevents it from doing it in a cross-domain fashion. So there's a lot of technical implementation details that I won't dive into, but again, these are some of the precursors to developing a system that's going to be successful at making it drop dead simple for people to view products and all this information in one place. So the other piece of this, obviously, I'd mentioned before, is projection. So you might have a team that's projecting or is has an image that's projected with a given CRS, and then they're producing it. But if someone's viewing that if they're viewing, say, a base map with some other CRS, all that stuff should happen transparently behind the window. There are some technologies, like if you were subscribed to a web map server, I don't know how many people are familiar with all this stuff, but with there's different ways to obviously produce products. And if you had, say, a web map server, you might be able to go and request and say, hey, this is the target source that I want you to deliver me an image with. But again, we're set up to accommodate where that's not always the case. It might just be some image that someone's generating and they want to be able to bring it into the system and share it with a team. So we're kind of set up not only to use great resources like WMS servers, but also to just, hey, give me an image, give me the corners, and make this available within the actual, to the team within the system. There's also things like document parsing. Hey, I have this great KMZ, it has all this information, but how do you parse and that compressed file? How do you make it available to end users? All that stuff has to happen, and you need a system to be able to make that available. Okay, so the goal here is to produce some type of end user interface such that someone could just check a box and they don't have to worry about the implementation details behind everything I just said. They can click a box, and whether or not, and these are real world examples where if you had a KMZ, a TMS, which is a tile mapping service, which is basically just a bunch of ordered tiles organized in folders. GeoJSON, which is a kind of vector graphic geospatial format, which is used really commonly. Whether or not it's a KML, whether or not it's thread server, which is supplying you the WMS, we make it drop dead simple that people don't need to worry about that. They say they want to be able to incorporate, say, a GML total optical energy product, and then we make it available to the team. Okay, so let me jump over. Don, is there any questions that maybe came up that I can address now while I switch over here? Share. I hope someone says something, because if I've just been talking for, I don't know how long, 30 minutes.
No, you're fine.
No one's heard. Oh, thank God. I was going to cry. All right. Share web browser. Okay. All right. So in theory here, you should be able to see my my web browser. Can you confirm that you can see this?
Yes.
Perfect. Okay. So, typically I would talk to some examples, but in this particular case, we have a mission that's active right now in the air. So IMPACTS is a mission. What is the IMPACTS? Is the investigation of microphysics and precipitation for Atlantic coast threatening snowstorms. And it involves the ER2, which you can see here, and the P3, which you can see here. So the ER2 right now is at about 64,000, almost 65,000 feet at about 338 knots. And the P3 is about 17,000 feet at about 233 knots. And this is real-time data that's coming in. They're actually running a flight today, which is very timely for this presentation. So I just wanted to kind of step through the tool and show you some of the capabilities. And I'll try to make sure I go slow because, again, I don't know how much latency there is on the website of things. But first and foremost, you could think about, individuals who, I just saw someone came up and said, that doesn't look like Atlantic. Yeah, that's true. I think they're going after storms and being opportunistic about it. So, but that is funny. Okay, so the main thing here is you could think about a system like this where, you have this kind of common operating picture set up, and you don't necessarily have to have everyone deployed at one, particular ground, some deployment site. Is that someone, halfway around the world, they can be getting the same information, they can be chatting with the aircraft, they can be making decisions and help participate, with mission decisions, no matter where they're at. And that's kind of a goal here. So I'm going to step through some of the functionality here so you can see that. So on the left-hand side here, what you wind up having is information that displays aircraft state and aircraft telemetry itself. And you can see they were probably flying some type of coordinated pattern here. And there's a number of simple things that you can do with the system. Like, for example, this varies considerably based upon, who you are and, what you're trying to do with the system. But just to give you a flavor of the type of information that's available, you can view real-time, aircraft position, as you can see here, along with wind vectors. And as I go through, I'm going to turn things on and off so things don't get too crazy. I'm going to zoom out here so we can see this. So you can do other things, like you can set up range rings, and I'll show you a way you can customize this in a second. But you can augment the aircraft icon itself as well as the actual track. You can set up very simple ways to be able to look at ETAs to certain distances in space. So that's also handy for kind of dynamical planning. And the same goes for the ER2 itself. You can also look through and view telemetry. So if you're on the instrument team and you want to be able to view your telemetry in real time, these are instrument telemetry status packets, they're called. And not only can you view this in kind of these tabular format, but you can also plot and visualize these in different ways. Just to give you a sense on kind of what can be customized, I give an example of the range rings here. There's lots of ways in which this can be used based upon, what you're after. You can set yourself up, different colors, range, all your preferences, you can change. And that makes obviously for quite a bit of flexibility depending upon, your role and what you're trying to accomplish. But there's things like range rings. You can customize pretty much any aspect of the display, including what telemetry parameters and instrument packages that you want to be able to pull into the system itself. So for the P3, these are what are available. For the ER2, it's going to be a different set of payload that's available. And, again, this makes it real simple for individuals who are on a particular aircraft team. In some cases, the status packets are very useful for plotting for other type of information. So mission scientists might use that information, like if the information is coming, say, from MMS in real time, that information might be used and used in a visualization or a plot to get some information about what's going on. So these are some examples on the aircraft state side. You can also do simple things where if you wanted to add, say, a satellite, in many cases for airborne science, as far as that's concerned, it's doing a lot of satellite underflights. Clearly, NPP is not in the area right now. PP, sorry about the radio silence. Okay, so we're over here in India. And you could do simple things too, where you can view the tracks. If you wanted to view, let's say, the next 5 orbits, you can do that as well. So a lot of things like this, which kind of give you some situational awareness. And for airborne science, obviously important to have really easy access to satellite tracks, because in a lot of cases, as I mentioned, they're doing underflights and a lot of calibration and validation type of missions. So you can do that not only for satellites itself, but you can do that for other platforms. So if you're participating, say from one mission and you're participating in another, then it makes it real easy to add other platforms as well. And I could check here for a second. Let's see. The WB is about to fly, and we have some NOAA aircraft up. But anyway, okay. So we'll go back over here to our impacts mission. Okay, so in addition to the aircraft state parameters, what you might also want to be able to do is have products that are made available to your team. And sometimes these products are kind of generic in nature. They might be GOES type products. And the system is set up such that, a mission scientist can say, hey, we want to make these products available to the entire team. Or you can search for a product and add it that way as well. But just to give you an example, so like say, for example, GOES 16, I want to be able to view, let's say, BAM 13, which I already had added here earlier. And, again, it doesn't matter the implementation details that this is a TMS type product. The researcher itself, if the researcher can go, they can get the information about when the product was last updated. They could view a color scale if that was available. But it really makes it very simple to add products and remove and hide them based upon, again, what the task is at hand. The other thing that we can have set up and it's used quite frequently is a way to view quick look information that's coming and provided by an instrument team. So one of the examples here is a Cosmere instrument, which is on the ER2. and they make a lot of this information available. And we can pick one of these here. I'd added again this earlier because I was checking it out. But this is a real-time, near real-time Cosmere information. Maybe the 30-second is probably, or 30 minutes a little bit better, because as they fly over, you're getting a bit of redundancy with this image. But hopefully you can see the power that, not only can, you look at where the aircraft is at, but you're getting real-time information about an instrument that is part of the actual payload of the aircraft itself. So that is available for, on a per mission basis. So this configuration is specific to impacts. Some other mission would have some other set of products that is going to be germane to what their requirements and needs are. So again, there's lots of examples here that I can show you, but again, they'll be fairly redundant. The other piece of the puzzle here is if you wanted to save you some other product. I don't know. We could search for products here. So if there was, say, for example, something that you're studying and is not part of the actual available product set, or if you just wanted to go and get that information, we bring in information from the NOAA Global Imagery Browsing Service, from SIMS, and there's a lot of different sources which we kind of bring in and make available in kind of this single interface. This one is from, I think, AOML. And this is a threads-based product. We also have, I think, access to the GeoCF, which I think I got to check that. But from kind of a product perspective, you can come in, you can view the product, you can change options, time steps if those are available, you could change the color scale. So it makes it real simple to go in and view products. So if you're, depending on where you're at in whatever the mission is, maybe you're doing some planning and some of this information is critical to kind of helping you kind of formulate the plan, maybe 48 hours or 72 hours before flight. Providing this within the tool itself is something that, is core to the actual tool. And it's as simple as saying, hey, MTS team, these are the products that we want to make available, figure out how to ingest it. And because we've done that over the years, this is kind of the result. Okay, so we're at 11:43. I want to leave some time for questions, so I'm going to jump through here and show some additional features. I'm going to hide.
Yeah, Aaron, we have a question too from Sam LeBlanc.
Okay.
Did the flight plan get integrated for impacts?
Yeah, so what we wound up doing was, let's see here. For the flight plan, we have a couple ways to do this. So what we've tried to do with this next system is set it up such that anyone within the flight planning team, they can upload an actual flight plan. So there are impact flight routes. So if we wanted to see like the latest ER2 flight plan, those can be updated within the system. And here is the latest ER2 flight plan that they're flying. And then the same goes, we can add the P3 just like that. But that is kind of the one piece of it. There's also tools in here for kind of ingesting and modifying flight plan. And those are part of this too, but they are very new. They were released right before impact, so I don't know how much use they're actually getting. Let's see if we can connect. I don't know why we can't connect. Okay, so the other piece here is tools. So, in addition to, viewing products, viewing telemetry, another piece of this is you have a lot of different users who may want to be able to use different aspects of the tools. One example of that is on the mission operations side. There's mission planners who are, their concern is with kind of vectoring and coordinating aircraft. So what we can do and what we've done in the past is set up tools that make it very, very simple for them to do whatever they need to do. So this is an example of a purpose-built tool that goes out and if you are on, say, the aircraft planning side of things, you might be looking at the IFR charts. So the IFR charts are part of there, and you might want to be able to go, okay, for a given line, I want to be able to run this line here and tell me the nearby nav aids that are close by, so I can get access to that information, and I can provide that information to the aircraft team so we can make a decision on whether or not they want to vector the aircraft or coordinate the aircraft in some way to sample that line. So this is an example of one of those tools. I'm going to remove that and I'm going to go back to here because this can get complicated very quick. But there's all types of measurement, airspace, weather reconnaissance type tools that, again, depending upon what you're doing, is available and very simply accessed within the interface itself. So if you were planning, say, for example, and you wanted to have access to, say, special activity airspace. Again, the tool is kind of at the centerpiece of not only mission product side, but also on the airspace side as well. And really is its importance is to integrate all that information in kind of this common operating picture. But again, there's so much information, there's not necessarily always the way to show and demo all this stuff in one go. It's kind of a lot to throw at everyone, I know. There's also a lot of customizations with the tool itself, from setting up the environment if you want to view multiple windows. So, here, for example, we might want to view this is just some basic setup, but we want to view, say, the AVS forward camera on the ER2, and we want to see that in real time. Maybe we want to see some, plot, as I mentioned before, some quick look plot that's available from provided by one of the instrument teams. The environment is set up such that you can customize not only the layout, but also, the information that's displayed within it. So if you wanted a couple maps, you can do that as well. So that is kind of the tool and the 50-cent demo of it. There's obviously a lot more to it, but I just kind of wanted to highlight some of those features and show you something other than just a bunch of slides here. So I'm going to go back to, let's see, share content. Okay, so I made mention of this, for earth science proposers, and the thought of whether or not they need to consider a decision support system like this is that anyone who is participating in the Airborne Science Program, no matter how big or small, they have access to this tool. So they would just either they can contact us directly, or we can get information through. When the SOFRS request is made, we can get information from internally, the Airborne Science Program internally. But some questions to just think about on if you're going to be leveraging and using some of the airborne science platforms, that these are common questions that often come up that I thought I would just bring up here, and whether or not you need decision support system in general. So one of the thoughts is, do you need real-time tracking? In some cases, the aircraft is going to go up, sample a very specific plan, and then come down, and that's it. So maybe real-time tracking is not necessary. Maybe you need an update every few minutes. Maybe you just want some situational awareness, and the tracker is sufficient where you can go get some information, and then, is the aircraft active or not, and then that's it. One of the main considerations is whether or not, hey, is the flight plan static, or is the nature of the phenomenon being investigated dynamic? Does it require ground coordination? Does the platform that we want to use even have some type of network, existing airborne sensor networking capability? For some of those questions, if they don't, we do have handheld Iridium and SATCOM devices that can be deployed, not only on an actual aircraft platform that may not be equipped with some type of internal tracking, but that can be leveraged for if you want to track some other type of research vessel, balloon, you name it. So that's something to consider and something to bring up and let us know, or the program know, and that's something that we can potentially, furnish if that's something that you need for your particular experiment. You also have to think about often is that all these tools are great, but this is web-based. So is there, and what are the ground network constraints that are going to be there, or at the deployment site? Because all this is great until you don't have really any kind of bandwidth, and then you're not able to use tools like this. So some of these factors and consideration, need to be, thought about. And this really kind of does make or break whether or not the tool can be useful or not. And there's some other ones here as well, which are pretty self-explanatory. Okay, so just to summarize here, Mission Tool Suite is a general purpose asset tracking decisional support tool. We've been kind of doing this for over a decade of operational applications, from small missions to very, very large missions. And, for recent, fire, wildfire research, as far as an asset tracking tool, there's applicability, for a tool like this beyond just airborne science itself. So in your own work, if you have, or a need for just a generic platform type tracking capability, that might be some discussions that that your team and ours should have, because the tool possibly can be leveraged for those type of purposes very easily. There's also the Airborne Science Public Tracker, which I had mentioned. The Airborne Science Public Tracker, you can access it through the Airborne Science website itself, and it just shows, what's happening with most of the NASA Airborne Science aircraft, as well as NOAA aircraft. So if you want to follow along and know what's happening, you can access and get that information there. Okay, and that's it for the presentation.